This is problem 1-7E on page 40. A man weighs 210 pounds force at a location where G equals 32.1 feet per second squared. Determine his weight on the moon where G equals 5.47 feet per second squared. Okay, so the man has a force applied to his body of 210 pounds force when the acceleration of gravity is 32.1 feet per second squared. The question is, what would his weight be in the alternate case where G is 5.47 feet per second squared? The key to understanding this problem is to realize that the man's mass is the same regardless of whether he's on the moon or on Earth, and so it doesn't really matter where he's at, his mass is the same. However, the weight is a result of the acceleration of gravity. So basically, there's a difference between weight and mass. In fact, weight is equal to mass multiplied by acceleration of gravity. So we can rearrange this equation to say, let's call this case 1 or state 1, and case 2 or state 2. Then the weight in state 1 would be mg1. In state 2, it would be mg2, two different accelerations of gravity. So if we want to solve for the weight in state 2 here, the weight in state 2, well, notice we could solve for the mass. We could go from here, solve the mass, weight over acceleration of gravity, and I'll do that. But before I go through that and find his mass, I'm going to show you how to solve this without that. So if we realize we can plug this in, then we'd have weight 1 G2 over G1. And so it's pretty easy to see or calculate his weight on the moon. All we need to do is take his weight of 210 pounds force and multiply it by 5.47 over 32.1. I'll drop the units here since they're the same. They're both feet per second squared. And let's see, we'll get an answer. 210 times 5.47 over 32.1. That answer is 35 points. Let's round it up. That's about the best we can do. But what about his mass? How much mass does this person have? Well, we can find out. That really is probably a little bit more instructive. The mass of the person is his weight over the acceleration of gravity. So that's 210 pounds force, which is a measured weight. Realize that weight is force, mass is not force. They're very different things. So 210 pounds force divided by the acceleration of gravity, 32.1 feet per second squared. Now here's the part that may hurt your head just a little bit. This pound force per foot per second squared, this force per acceleration has dimension mass. Okay, that's the simplified dimension. That's the primary dimension that this reduces down to. It's not a pound mass. It's not a slug. Well, it may be a slug. I'm not as good with slugs. In fact, I think that is a slug. But here's the point. This is mass. Now, what I like to do is convert it to pounds mass because that's where students get confused. Now, a pound mass and a pound force are two totally different dimensions. You can't, they're related, but they're not the same thing. So you can't just say, well, 210 pounds force is 210 pounds mass. It doesn't work that way. Okay? So let's see, how does it work? Well, 32.2 pound mass feet per second squared, which this is all force because it's mass times acceleration, is 1 pound force. Now in this class we're going to use pound mass extensively, so you need to understand this. You may have learned this as G sub C. Okay? Don't think of it as G sub C anymore. Think of this as a conversion factor. I hope the calculator still works. Yep, there it is. It even still has the answer. Okay, so this is just a conversion factor. The 32.2 pound mass feet per second squared is 1 pound force. It's like 12 inches is 1 foot. It's the same thing. They're just different unit sizes for the same dimension. So anyway, you can see that the pounds force will go away. And we're going to get pretty close to 210, which makes sense because this acceleration of gravity we're given is pretty close to a standard number. But let's calculate it just to finish things off. So times 32.2 divided by 32.1 equals 210.7 or so. And the feet per second squared go away. This is pounds mass. So there's the man's mass. Here's what confuses students. Frequently they see, usually we use 32.2 for our acceleration of gravity, and what they'll do is they'll say, well, two 10-pound force, two 10-pound mass, they're the same thing. So pound mass and pound force are the same thing. That's not the case. Only on Earth is the numerical value of your weight equal to the numerical value of your mass. That's the only place where that happens, and it will only happen when the acceleration of gravity is 32.2. If it's something different, if there's a slightly lower acceleration of gravity, then it still won't come out that way. The numerical value of your force and your mass will be a little different. But anyway, here's the key. There are 32.2 pound mass feet per second squared per 1 pound force.